All right. Here we go. Math 2. We've got 7-3 special right triangles. And this time we're going to look at special right triangles that are with the angle measurements of 45, 45, and 90. Our question today is, if an isosceles triangle has a hypotenuse measuring 2 root 6, what steps are needed to solve for the legs of the triangle? So what we got today is we've got a triangle that's going to be an isosceles right triangle. Now, since it's isosceles and right, well, then we know that this angle has to be 45 degrees and this angle has to be 45 degrees. Because in an isosceles triangle, the base angles are congruent to each other. So if this is 90 in a triangle, they all have to add up to 180 degrees, triangle sum. So that has to be 45 and 45, because 45 plus 45 plus 90 equals 180. So all of these problems where they're 45, 45, 90, they're going to be isosceles right triangles. Now what we do is there's a pattern for these particular types of right triangles. The pattern, instead of using a squared, b squared, and c squared, the pattern is going to be slightly different. So we're going to say this is A, and this is A. So since both legs are the same, we're going to call them both A's. But there's a relationship between the legs and the hypotenuse on these types of triangles. Remember, it only works for isosceles right triangles. The pattern is whatever A is, the hypotenuse is A times root 2. It's going to work like that every single time. The legs are going to be the same, and they're both going to be A. The hypotenuse is going to be whatever the leg was times root 2. You can actually do the Pythagorean Theorem and see that it works. You can do a squared plus a squared equals a root 2 squared, and it would work out. We're not going to do that because we're just going to move into the notes. So what's different compared to the Pythagorean Theorem? Well, here's the big difference. Number one, in the Pythagorean Theorem, you were given two sides and then asked to find the third side. In a special right triangle problem, you're only given one side, and then you have to find the other two sides. You can't do 16 squared plus x squared equals y squared. You have two different variables there. You couldn't solve for that one. So on this one, we notice that these two angles are exactly the same, which means they're both 45 degrees. Using triangle sum, we would be able to figure it out. So that means this is an isosceles right triangle. Since it's an isosceles right triangle, we'll call this side A. We'll call this side A, and this side is A times root 2. So if A is 16, then X is also 16. Because these two legs are the same in a 45, 45, 90 triangle. Now Y, we just said that A was equal to 16. So if I plug in a 16 right here, the hypotenuse would be 16 root 2. So Y is 16 root 2. Done. That's all we had to do. Let's look at the next one. This is isosceles and right, meaning this angle is going to be 45 degrees, and this angle is going to be 45 degrees, because those are the base angles. And in an isosceles triangle, the base angles are congruent to each other. So we know that we can use the 45, 45, 90 pattern. Well, this side would be A, this side would be A, and this side would be A root 2. So I want to find out what A is, but right now all I know is that A root 2 equals 10 root 2. So I'm going to write that down. A root 2 is equal to 10 root 2. Now I said before this is A times root 2. So how do I get rid of multiplication? I divide by root 2. So I'm going to divide this side by root 2. I'm going to divide this side by root 2. And so these two radicals reduce each other. And we can reduce radicals with radicals. We found that out when we were simplifying radicals, so that reduces with that one. And we find out that a is equal to 10. So what's x? X is a, and a is 10. So x is equal to 10. What's y? Well, y is a, and a is equal to 10. So y is 10. And that makes sense because we already knew those two legs were the same length. All right, let's make it a little bit harder. This angle is 45 degrees, which means the bell rings and interrupts my lesson. Now it's over. All right, so this angle is 45 degrees. So that angle has to be 45 degrees because these three angles have to add up to 180 by the triangle sum. So that means that these two sides are congruent because its base angles are the same, so the sides are the same. Well, that already tells me that x has to be root 6 because those two are the same. So I'm going to say x is equal to root 6. Now, these are the a sides, and this is a root 2. Now, we just said that a is equal to root 6. So what's a root 2? Well, a is root 6. So a root 2 would be root 6 times root 2. That's a root 2. So what's root 6 times root 2? It's root 12. And then we are going to simplify. This is 2 times 6. 6 is 2 times 3. I got a pair of 2's right there. So it looks like this side is root 12 because we did root 6 times root 2, which was root 12. And then I'm simplifying it, and I get 2 root 3. All right, almost there. So again, we've got a 45, 45, 90 triangle. Oops, 45, 45, 90 triangle. So this is a, this is a, this is a root 2. So I know that the a root 2 side is equal to 10. Now I want to find out what a is because these two are both the a sides in the pattern. So I divide by root 2 on both sides. So I find out that a is equal to 10 over root 2. But remember, we're not allowed to leave. Oh, you couldn't see all that. I'm sorry. Today's not a good day. All right, so we're going to get rid of the denominator, the radical in the denominator. So we're going to rationalize the denominator. So here I get root 2 and root 2. So I end up with 10 root 2. And then root 2 times root 2 is just 2. And then my last step is, since these are both whole numbers, I can reduce them. And I find out that a is going to be equal to 5 root 2. And b is also 5 root 2. There's my final answer. All right, that's all I got for you. Sorry about not moving the page. I'm just not all there today. All right, you guys have a great day. Look at that, 9 minutes, 10 seconds. Pretty sweet. All right, math hard. See you later. Bye-bye.